Hi guys, this is Miss Fendall. I'm not here today obviously, so I'm going to have you guys watch this video and go through the packet with me like if I were to be here. I know it's like kind of weird and a little awkward, but we're just going to get over it. And it's really important that you guys have a day to review linear versus exponential functions, and so I wanted to make sure that you don't miss it just because I'm out. So tomorrow I'll be back and we'll be doing some more review for your exam on Module 3, but today we're going to like specifically focus on exponential and linear functions and the difference between them. So what you should have in front of you right now is Module 3 review, the packet that looks like this, something to write with, and then if I write on this paper, you're going to also write and follow along as well. Also, I'm going to say like at times, hey, pause this video and try to do some work or something like that. And so like whoever is in the room with you can just pause it and give you time to work on that problem, and then when you push play, then I'll talk about the answer and you can check your work. So as you can see, we're going to compare side by side a linear model versus an exponential model. This was a lot of stuff we talked about in Module 3, so I want to make sure we just like super quickly review it in one day. So what I've wrote down is the general form of a linear model, but I've done it in two ways. So you need to write this down as well. I'm going to kind of like zoom in for you guys. So you need to write down the linear model. We all know that the equation of a line is y equals mx plus b. But today I'm actually going to use a instead of m because I want to make sure that we can compare exponential and linear. So I'm going to use a and b for both equations. So instead of m, we're just going to use a, but a still means slope and b still means initial value. So take a second and make sure you write that down. Y equals ax plus b, where a is slope and b is initial value. And then we're going to talk about an exponential model. So we all know what an exponential function generally looks like. It generally has some sort of increase like that. But an exponential model's regular equation is y equals b times a to the x power. And we're going to write y equals b times a to the x power because we're going to use b and a for both linear and exponential. Now b is still, just like over to the left, the initial value, or when x equals 0. So the starting point. And a is still the growth or the slope. But I'm going to use for exponentials the growth factor. So that could be going down or up, but it's some sort of growth factor. So make sure you get all of that down. Now I'm going to talk about what a and b really mean, but I kind of already wrote it. So we're actually just going to say a, b again, a, b again. B is initial value, initial value. But also, we can also talk about it as the y-intercept for both. And then a, in the linear, we really call it the slope. And in the exponential form, we call it the growth rate or the growth factor. Again, I'm just like reminding you of this. I know we just wrote it down twice. Now I want to show you an example. So the example I'm going to give is y equals 2x plus 3 for a linear model, and y equals 3 times 2 in parentheses to the x power in an exponential model. I hope I'm not going too fast. If I am, teacher, feel free to just like pause it and have them time, give them time. So we've got two different functions here. We've got 2x plus 3 and it's linear. We've got 3 times 2 to the x power as an exponent, and that's an exponential function. Now, the rule that we have here for finding f of x plus 1, the rule for finding f of x plus 1, aka finding the next term, here we know that to find the next term, we're just going by the growth factor of a plus 2, the slope. So every time we increase, we go up 2, like rise over run. And then here we know that because it is a 2 to the x power, it means it's doubling. And it really means, so doubling is times 2. So we've done this before where we look at the patterns, plus 2 or times 2, and we decide if it's linear or exponential. So let's make some tables to show this. Let's start with x, y on both. x, y on both. So we should know immediately, and I've talked to you a million times about this, that a linear function means that it's going up by a constant rate of 2. A constant rate of 2. We also know that this plus 3 means it's the initial value. So if it's the initial value of 3, it means that when x is 0, y is 3. And then we have our slope, or our growth factor, of 2. So every time we increase x by 1, we increase y by plus 2. So 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, and that would be when x is 2 or 3. So we could make the first couple of points from a table just by looking at our growth factor and our initial value, or our slope and our y-intercept. We can do the exact same thing if we look at an exponential function. An exponential function still has an initial value, but remember, the b is in the very front of the equation when we talk about an exponential model. So the actual initial value, or the y-intercept, is the first number. So here it's going to be when x is 0, the first number is actually 3. That's the initial value. Then our growth factor is doubling because of the 2 here, so we know it's doubling, or times 2 each time. So as x increases by 1, we know y is going to double. So 3 doubled would be 6, or times 2. 6 doubled is 12, and 12 doubled is 24. And as you can see, I've modeled this down here on the graph. You can see our initial value for the linear function was 3, and we started right at 3. That's the initial value. Our initial value is also 3 for your exponential model, and you can see the y-intercept starts at 3. Because linear is constant, this slope is going to be a straight line. It's going to rise 2, run 1, rise 2, run 1, because the slope is 2, the growth rate is 2. And so we have a straight line. We have 1, 5, 2, 7, plotted these, 3, 9. And if I plotted the same exact thing over here, but I plotted my table, it's 0, 3, 1, 6, 2, 12, 3, 24. 0, 3 is my initial value, 1, 6, 2, 12, 3, 24. But if you notice, it's obviously increasing by a non-constant rate, and it's going to continue to increase if I were to continue to move this graph forward. I'm going to add arrows here because in my examples, I don't actually have a stopping point, so I should show that this goes on forever. But if I were just to graph these 4 points, this is what it would look like. And now in words, I'm going to show you what this could be. An example of a story problem that modeled this exact situation could be that Charles had $3 in his bank account to start, so that's his B, and earned $2 per week and as an allowance. So $2 per week, that's my example, or my keyword to know that this is my slope or my growth. But I know reading that it's constant. It's $2 every single week. Now if I look over here, there were 3 goldfish in the tank. So again, that's to start, so that's my B. And then the population doubled every month. I bolded doubled because that means that it's not actually going to increase by the same amount. It's going to multiply by 2, which is going to change. Multiply by 2, it's going to be adding 2, and then 4, and then 8, and etc. So just take a second, make sure if you need to pause this, make sure you get everything down on this front page, because this is really important. The reason I'm doing this side by side is so that you can see like what is the really big difference between a linear and an exponential model, and how can I actually use word problems here, down here, to create something like this myself. So then once you've got that down, we're going to go ahead and flip the page. We are going to flip the page and start our exercises. So, for each table below, assume the function f is defined for all real numbers. Calculate delta f. Now, this little triangle means delta, and in math, really that just means the change. So calculate the change in f, meaning you take the old point and the new point, and you see what the difference was. So how did I get from -3 to +1? We've done this plenty of times, but now I'm just showing you